Okay, it's been a pretty exciting month for the Aero. On February 23rd, a little over a month ago, I did a little review on the Aero and I mentioned how tightly coupled the software driving it was to the performance that you could get out of it and how it happened at a lot of levels. Well, all those levels got updated since then and we got to see some things that are amazing. So a month ago I was saying I was getting iRacing at 35 ppd and most other applications at 27, which is okay. By comparison, an index is 13 to 14 ppd. Reverb G2 is like 22 to 23 ppd. So 27 is still a little better, but now 35 ppd is my baseline. I'm running everything at 35 ppd and higher, and it's pretty amazing. So the software started to get updated. So on March 6th, Varjo came out with new base software, and their base software included 2-to-1 and 3-to-1 reprojection, motion smoothing they call it. So some people without 4090s could actually get things to run better on it. I did a couple test runs, and for iRacing at 35 ppd, running it at 2-to-1 reprojection, I was seeing low 20s on my GPU for percentage, so that was pretty amazing. In DCS, I got it down as low as 48% at, well, actually at a higher than 35 ppd. We'll get to that. So I've got all my Steam VR games running at 35 ppd now. That was mostly on me. I just needed to turn the MCAA down on every one of them. So they're either at 2 or off, and at that resolution, the anti-aliasing is not nearly as critical, and they just all look fantastic. Half-Life Alyx is a very efficient title, and I can still leave all the settings up 100% on that, and at 35 ppd, and it looks fantastic. So let's get back to DCS. This shows how multiple levels make a huge difference. So let's see. So since the 23rd, on March 6th, Varjo released their base software. Then just a few days later, on March 10th, DCS put out their new multi-threaded open beta. They also, in that update, improved their native support of the Varjo SDK. This opened up what another person, Matthew Buccineri, I may have butchered his name, as a result of what Eagle Dynamics put out, he was able to add an OpenXR layer template to support the native dynamic foveated rendering in the Aero in DCS. So I was having trouble, I shouldn't say trouble. My system was working really hard to drive 27 ppd, and now I'm getting the full maximum of this headset in DCS. I'm getting 39 ppd, which it's absolutely sharp and phenomenal. I mean, just, it's amazing. That was a 44% increase in pixel density, going from 27 up to 39. And I think it's a little more than that, because if you look at how people do dynamic foveated rendering, normally there's like some additional sharpening or anti-aliasing, basically a little more image quality tweaks being done for that very center of where your eyeball is looking to make it look better. So even though going from, say, 35 to 39 ppd isn't a huge difference, it's only 11%, I think it's sharper because I think there's some more going on. So while I'm throwing a lot of these ppd numbers around, let's look at this a little bit more carefully. The aspheric lenses are focusing light in a lot of different ways, and one of the things that the Varjo XR3 did was put additional displays in the center of the lenses, so that they had the retina display in the very center, and which is a great idea. What they did for the Aero is they tried to reduce the complexity and the cost, but they're still focusing more pixels into the center of the lenses. So when I'm saying 39 ppd, that's most likely the maximum that you're getting when you're looking through the middle. So it's got the eye tracking going, and when you're looking at what you're reading on the display or off into the distance, you should be getting 39 ppd. But as your eyes wander away from the center of the lens and it's tracking, it'll be doing the best it can, but the pixels will be spread out a little bit further as you go out, but still incredibly sharp. So not complaining, and I do like the way they did that, because most of the time you are looking pretty close to the center of your lenses and you just get an amazingly sharp view. So the fun part about this is on previous headsets I didn't have eye tracking cameras, and you just put it on, everything works. Now with the Aero, there's a little more maintenance involved, because as an example, when I upgraded my computer up to Windows 11, the cameras lost their permission for the software to reach them, so I had to go into the system security and adjust the permissions so that the software could actually look at the eye tracking cameras and let them run. And well, that's great. So it's working again. And then recently it stopped working, and to get it working, I installed the latest NVIDIA driver update. I was only one release behind, but for some reason my eye tracking just failed. So put the latest driver in, and now it's working again. So you can see, once again, there's more maintenance involved here. So we have new Varjo base software, NVIDIA driver update, DCS had their multi-threaded update, and then there's new OpenXR software that you're installing in order to leverage this, which is, I'm just amazed. I mean, this thing is it's just getting better all the time. There was another piece of software written by Bernard, and his last name is escaping me at the moment, to handle issues with RedShift, which I understand is an artifact of Varjo's fix to the chromatic aberration that they had when they first launched the headset. I haven't noticed this RedShift problem, and I understand it's IPD related. Currently I'm at about 64.5 millimeters IPD, interpupillary distance. And what I'm hearing is that when you get beyond 66 is when you start seeing this RedShift issue. And aspheric lenses are very complicated, and they're warping a Bayer pattern. The pixels on the actual display itself have individual red, green, blue, and it's moving them to focus them in something that's supposed to be rectilinear to your eyeball. And in the process, these pixels get skewed a little bit, and it can cause issues. So through software, they've fixed the chromatic aberration. I can't see the RedShift issue, but other people do. Anyway, so there's a software out there to take care of that. And then on top of all this, and I've been spending a lot of time just getting things tweaked to work right, I added this little thing. This is an HTC Vive Tracker 3. I 3D printed a mount for it that bolts straight down to the top of the vertical profile. And what this is used for, or what my hope it's going to help with, is motion compensation. So now that I have a full chassis motion rig, moving me all over the place, the idea is yet another OpenXR plugin reads the input data from this and uses it to correct what I'm seeing in the headset. So as an extreme example, someone recently told me, and they've got an SFX 150 system that, as he put it, would move him enough to put him out a window or through the roof of a car. And with, large changes in motion. My D-Box system doesn't have that dramatic motion. I haven't found myself thrown out a window or through a roof of a car or through this, through the canopy or something in DCS. I haven't had that issue. I'm mostly looking to just improve my experience. So I'm just starting to play with this. Installation is pretty simple. And then once you have installed the OpenXR piece for it, you have to modify an INI file. In this case, I had to tell it I had a Vive Tracker. When you bind the Vive Tracker in Steam VR, you have to set a position. I've got it set for left shoulder. Inside the INI file, you have to map it to the same thing, so it's left shoulder. And then for this thing, I needed it was like a early initialization option set to 1. And then it would actually come up. And then there's adjustments to filtering. So I'm expecting that software is going to evolve over time. It seems like there's some vibration dependence or issues now. And so, as some of you know, I've got a full tactile system on this. So I've got 2 butt kicker concerts, a couple TST 429s, and then there's some more exciters on the back of the seat. And they feel really good. They're all isolated though, on purpose, so that the energy from the transducers would go into my feet and into my back, butt, whatever, in the seat. So that kind of shields them from this. But the D-Box haptics are full chassis vibrations. So if I was in iRacing and I had a rumble strip, and it gave me a real nice, feeling as I went across it. That went right into this, and it popped me sideways, and so there was a little more correction than I wanted. So, as I said, I'm still dialing it in. It's a work in progress, but it's something interesting I'm working on to improve the VR experience some as well. So, I think that's pretty much all I wanted to cover today. I was really concerned in the last video because I mentioned that I could only get 35 ppd in iRacing, and now I've got it across the board, and then 39 in DCS, which is really, it's kind of exciting because I got to actually see the real potential of the headset. I mean, at 39 ppd, it is sharp. It's just, it is quite an experience. So I'm really enjoying that. If I was going to continue the review just a little bit, there's only one thing about this headset that would, just be icing on the cake if they could take care of it. And there's a little bit of a motion blur that you get in it sometimes. It's something you get used to, but it's there. And I notice it more in some applications than others. And it's funny because you learn, if you're in, say, a shooting game, if you move your head quickly, you don't really notice it. You're just like, you snap your head, focus, shoot, snap your head, and you're fine. If you're slowly moving your head, you don't see a whole lot. There's an in-between space where you're moving your head at a certain speed and you start seeing it a little bit. And like I said, I'm not seeing it in some games, or at least I'm not noticing it as much. I know it's there, but that is one thing that I hope they take care of. And I do know it's in the software and it's not in the hardware, because if you're sitting somewhere without moving your head and there's a whole lot moving on the screen, there's no blur whatsoever. It's sharp. So it all has to do with how they're handling motion and the viewpoint that you have. So I'm still hoping that they'll get that resolved in software. And given the amount of software updates we've seen in just the last month, I mean, NVIDIA, okay, we're going to expect a new update from them every month or so. Varjo, I'm betting that's going to be mostly like once a quarter or something, but I've only had mine for a little while now. The OpenXR community is busy. We've got some great people who I really appreciate their efforts. The guy who did this, he goes by, was it Buzzlebee or something like that, and he put that out there. It's free of charge, and you can contribute and support these people in their efforts. And I've made a point to support the guy who's doing this, and I'm going to make sure I go back and send something to the other guys as well. They're putting in a lot of effort. They could be playing games and doing stuff, but instead they're writing code to make the gaming experience better for all of us. So I'm very happy these people exist. I've shared this mount for the tracker on Thingiverse, and I'll post a link to that as well. I'll post a link to the other OpenXR updates that these people have been working on. So just fantastic effort. Thank you so much, all you guys who are putting so much effort into making my experience better and the experience of a lot of other people better. There's one more thing I did want to bring up, and it's related to the support of different headsets. So we still have the Pimax Crystal out in the horizon somewhere, and it's starting to look like it may start shipping in May, in some numbers. And I guess they're hoping to have that. They're hoping to have their eye tracking working by the end of that. And there's efforts involved. There is efforts out there to add Pimax support. The same guy who brought us the native dynamic foveated rendering for DCS has been working on OpenXR for the Pimaxes. But it sounds like Pimax is kind of not documenting their SDK, making it really hard for people to add this. And as a public service announcement, if anyone at Pimax happens to see this, it would be really helpful, I think, to your company, Pimax, if you were to support some of these great people who are giving of themselves to improve the experience for others. Because if the Pimax arrives, and the eye tracking is working, but there's no documentation or way for other people to figure out the SDK to potentially build these improvements into them, it's your company that loses out, and the people who buy your headsets that don't get the value add that these people who are giving them their time and effort to make the experience better, anyway, I'll stop there. Just please throw them some bones, give them a little documentation, give them something to work with so that they can support your product better, so that it's a better experience for all those users who are planning to shell out money for your headset. That's all. Thanks.